Okay, this lecture is about Shannon Fano code. Shannon Fano code is one type of source coding. As you know, the source coding is one of the important block for digital communication. Information it is one type of information source that is used to remove the redundancy from the information which and so reduce the data rate. The source code requirement mean that the first one is to reduce the redundancy from the data rate, but the output of encoder must be in binary form. The second one, the source code must be unequally decodable so that the original source sequence. The types of source code, there are many types. There are two categories, must be divided into two categories according to the length of source code. One of them is fixed length code, which is used for non-probabilistic, and so it has low efficiency. The second type is variable length code, which is used for non-equal probability, and so it is high efficiency because it removes the redundancy effectively. There are many types for variable code length, which is Shannon Fano code, and second one Shannon code and Hoffman. In this lecture, we talk about Shannon Fano code. Shannon Fano code, it is in the first step, there are four steps is used for done this code. First one is to arrange the symbol from higher level of probability to lowest level of probability, and a second step to divide the set of probability into two half, one which we use for to divide the probability, the sum of probability, which is approximately equal to 0.5. As we an example, all symbols that have first digit for their code assigned, and repeat the steps so to approach the final step. For example, we have six probabilities which have 0.35, 0.21, 0.15, 0.12, 0.1, 0.08. The first step is to arrange the names of probability from x1 to x6 as an example. The second step to arrange the probability from high level to low level, as we see. We started by 0.35 and we to reach 0.08. The step 3 is to divide the probability into two type or two half. Each one have approximately 0.5 or reach the lower variant between two half. The second one, now we put the first code that is have 0, 0 for upper half and 1, 1, 1 for lower half. The final step is to divide the subgroup into another group and subgroup which have 0.35 and 0.2. Each one have put in alone and a group alone, and the lower group or the lower group is divided into two subgroup which have summation of each one, but is lower, which have lower variance. Now we put upper one is 0 and lower one is 1, and so this group have upper one is 0 and lower one is 1. Now the final step is to divide the subgroup to each one and alone group, but and so put the final step to put the code for each one. Now we have the length of code for each one, which have 2 bit for first one and second one, and the rest have 3 bits. Now we need to calculate the efficiency of this code. The efficiency can be calculated according to this law, which have h of efficiency is divided h of x over average length LC product by 100. The h of x means the average of sales information, which is calculated by according to this law, which is mean that each one of probability is product by logarithm of this value of such value, and summation or added to the another one, where each one of probability is product by logarithm for such probability. But because we have not logarithm for logarithm 2, so we can use ln instead of logarithm to can calculate it by small calculator. So each probability is product by ln of such probability and added with another, and added with all probability each one product by ln of such value, and summation of all this probability is divided by ln 2 to get the final value of h of x. Now we can calculate the average length according to this equation, which means that each probability must be produced by its length, as we see in the table, that the length of each probability must be produced by its probability. As we see here, probability is produced by its length and added with another probability which is produced by its length, and so on, so we can get the final value of LC, which is 2.45. The final step is to divide the h of x over LC and product by 100 to get percentage, and we see that the efficiency is very high for this type of code, which is equal to 0.97, which is very high as compared with another type of source coding that is have lowest value of efficiency. As we see now, it is very high, so that the redundancy is very low.